close your eyes for a moment and imagine the universe as a vast, endless tapestry. Stars shimmer like diamonds scattered across velvet. Nebulae drift lazily, clouds of gas and dust glowing faintly in the darkness. And somewhere in this vastness lie black holes, cosmic enigmas that defy our understanding, places where gravity reigns supreme and time itself bends. Black holes are born from the death of stars, yet they are far from simple. They are paradoxes, objects of destruction and creation, darkness and illumination, chaos and beauty. Imagine a star many times the mass of our Sun. Over millions of years, it burns fuel in its core, fusing hydrogen into helium, helium into carbon, and onward. Eventually, the star's energy supply wanes. The outward pressure that held it against the pull of gravity fades, and the core collapses inward under its own immense weight. In an instant, a singularity is born, a point of infinite density, surrounded by the event horizon, the ultimate boundary. Beyond this threshold, nothing can escape, not light, not matter, not even time as we know it. The singularity itself is a concept both terrifying and mesmerizing. It is where our conventional laws of physics crumble, replaced by the exotic mathematics of general relativity. The curvature of space-time becomes infinite, creating a region of the cosmos that we cannot directly observe, only infer. And yet, though unseen, black holes announce their presence through the way they influence their surroundings. Stars orbiting an invisible mass, gas heated to millions of degrees as it spirals inward, X-rays and radiation released in brilliant flares, all signs of the hidden giants at work. Let us take a moment to consider the different kinds of black holes. Stellar black holes are the most common, remnants of stars several times the mass of our Sun. Intermediate black holes, rarer and more elusive, breach the gap between stellar and supermassive black holes. Then, at the centers of galaxies, lie the true behemoths, supermassive black holes. Sagittarius A*, the giant at the heart of the Milky Way, weighs 4 million times more than our Sun, confined within a region smaller than the orbit of Mercury. These supermassive objects influence the formation and evolution of entire galaxies, silently orchestrating cosmic dances on unimaginable scales. As matter falls toward a black hole, it forms an accretion disco whirling maelstrom of gas, dust, and stellar debris. Friction and gravitational forces heat this matter to extreme temperatures, causing it to radiate brightly in X-rays. The black hole itself remains invisible, yet the surrounding light offers a window into its existence. Imagine watching this disk from afar, the glowing material spiraling ever inward, a cosmic whirlpool slowly disappearing into darkness. Black holes are not only destructive, they are transformative. By drawing in matter, they can trigger star formation, sculpt galaxies, and release energy that shapes the universe. When two black holes collide, they send gravitational waves rippling through the very fabric of space-time. These ripples, detected for the first time by LIGO in 2015, let us hear the universe in a way once thought impossible. The collisions are violent, yet there is an elegant symmetry in the spiraling dance of these cosmic titans. Imagine, for a moment, two black holes orbiting each other, spiraling closer with each rotation, stretching space and time until they merge in a flash of pure gravitational energy. History has always played a part in our understanding of black holes. In 1783, John Michael suggested the idea of dark stars, objects whose gravity could trap light. Carl Schwarzschild, decades later, solved Einstein's equations, predicting the structure of a black hole. And in modern times, Stephen Hawking proposed that black holes emit radiation, slowly evaporating over immense spans of time. This process, known as Hawking radiation, defies intuition, revealing that black holes are not completely eternal. Even the most massive, seemingly invincible objects are subject to the quiet passage of cosmic time. Let us now drift inward, toward the event horizon. Imagine yourself approaching this boundary. Space begins to stretch and distort. Time slows. The familiar rules of physics start to falter. From this vantage, one could see the universe outside continuing its dance, while moments for you stretch into eternity. This is gravitational time dilation. The closer you are to a black hole, the more time slows relative to the rest of the cosmos. It is a reminder of how fragile and malleable our perception of reality can be. Black holes also provoke deep theoretical questions. What happens to information that falls inside? The laws of quantum mechanics suggest information cannot be destroyed, yet the classical view of black holes implies it vanishes. This is the famous information paradox, a puzzle that continues to challenge the greatest minds in physics. Some theories suggest that black holes might be connected to other regions of space-time through wormholes, or perhaps even gateways to other universes. While speculative, these ideas invite us to imagine a cosmos far more intricate and mysterious than we had dared to dream. Consider also the phenomenon of supermassive black holes consuming entire stars. Tidal forces stretch and tear the star apart in a process called spaghettification. Gas and plasma spiral inward, releasing enormous energy before vanishing beyond the event horizon. From afar, this cosmic destruction becomes a luminous spectacle, a reminder of both the violence and beauty inherent in the universe. As we reflect on black holes, we encounter themes of impermanence and transformation. They are both destroyers and creators, shaping galaxies, influencing star formation, and emitting radiation that will outlast civilizations. Even in their darkness, they illuminate the boundaries of our understanding, inviting us to explore the cosmos with curiosity and humility. Now, let us expand our vision to the larger cosmos. Black holes are everywhere. They quietly influence the rotation of galaxies, the behavior of nearby stars, and the dynamics of galactic clusters. They are engines of cosmic evolution, invisible yet profoundly felt. Imagine looking at the night sky, knowing that hidden among the stars are these titanic objects, shaping the universe silently, relentlessly, beautifully. Take a deep breath and imagine the universe as it truly is, a vast, interconnected web of matter, energy, space, and time. Black holes are the extreme nodes in this network, points of immense gravity and mystery. They are reminders of the vastness of the universe, the limits of human knowledge, and the infinite possibilities that lie beyond our understanding. Even as we study black holes through telescopes, mathematical models, and gravitational wave detectors, we are only beginning to grasp their true nature. Every discovery leads to new questions. Every observation hints at new mysteries. They are both a challenge and an invitation, a call to meditate on the beauty, complexity, and infinite depth of the cosmos. And so, in the quiet of your mind, let yourself drift through this cosmic tapestry. Picture the accretion disks, the spiraling mergers, the faint echoes of gravitational waves. Let the enormity of space and time wash over you. Black holes are not just objects in the universe, they are gateways to wonder, contemplation, and awe. They remind us that even in darkness there is beauty. Even in silence there is voice. Even at the edge of understanding, there is the thrill of discovery. As this journey continues, remember that black holes are part of a larger cosmic story. They are not isolated phenomena, but threads in the grand tapestry of existence. From the smallest particle to the largest galaxy, from the birth of a star to the death of the universe, all is connected. Black holes remind us of our place within this vast, intricate, and ever-evolving cosmos that is at once comprehensible and infinitely mysterious. So, let us breathe deeply, sit in stillness, and contemplate the silent power of black holes. Let their darkness illuminate your imagination. Let their mysteries inspire curiosity. And let this reflection be a meditation on the infinite, the unseen, and the beautiful. For in the end, black holes are not only objects of science, they are mirrors of our own wonder, invitations to explore the universe within and beyond ourselves.